functions. Graph a cotangent function. Graph two full periods of y is equal 1.5 cotangent x minus pi over 4. So this kind of the function is of the form. So let me write the general form of this function. The general form y is equal to the a cotangent of bx plus c. Okay, this is bx plus c. But first of all, let me write here the parent function is cotangent x, and we already know the point that is going to divide this in two symmetrical sides. The function, the parent function, is going to be x is going to be n pi over 2. So n is element of z. So n is any integer. Also, the asymptote is going to be n pi. So those are some critical points that we can say for the parent function cotangent x. But now let's see here. Let's analyze this function. If we are looking for a, here signifies the vertical stretch or compression, but in our case we have 1.5. It means we have a vertical compression. And here inside, let me see the period. The period is equal with pi divided by b, and in our case b is 1, as we see here. B is here because we don't have any number, is 1, and pi divided by 1 is just a pi. So this is the period. Okay, if the period is the same like is in the parent function. The period for the parent function cotangent x is a pi, so it doesn't change anything. But the phase shift is going to shift here, so the phase shift is going to shift because x minus pi over 4, if is equal with 0, so x is equal with pi over 4. And now the parent function we already know is located in pi over 2, so the point that divides into symmetrical sides of the graph of cotangent x. But now because we have a shift here, is the phase shift is pi over 4. Whenever is a pi over 2 plus pi over 4 is going to, pi over 2 is going to shift for pi over 4, and pi over 4 is going to be, pi over 2 is 2 pi over 4 plus pi over 2 is 3 pi over 4. So this point here is a 3 pi over 4. There is going to be. But now if we are going in the left side, now to find the other point, because the period is a pi, if I am subtracting minus pi to the left side, it means here is going to be minus pi over 4. Okay, because pi minus pi plus 3 pi over 4 is minus pi over 4. If I'm going in the other side, plus pi here is going to be a 4 pi over 4 plus 3 pi is a 7 pi over 4. So 7 pi over 4. So those are the location where is going to the graph of the cotangent function, where is going the cotangent function to intersect in x-axis. Okay, but now we are looking to find the asymptote. Let me find the asymptote. Okay. The asymptotes is the asymptotes, for example, in the function here, the parent function is n pi, is a pi. Everywhere there is a pi, but because we have a shift for pi over 4, so the asymptote here is going, the asymptote x is going to be n pi plus pi over 4. So here is going to be the general form. And now if we are looking, for example, if n is equal 1 pi plus pi over 4 is going to be 5 pi over 4 in this position here, 5 pi over 4. But here is if n is a 2 times pi plus a pi over 4 is 8, 9 pi over 4. Here is a 9 pi over 4. And this can continue forever. But in the same way, it's going in this side here. For example, if it's a 0 here, if it's a 0, then it's going to be here a pi over 4. If n is a 0, is a pi over 4. One asymptote is going to be here. Is a minus 1. Minus 1 plus pi over 4 is minus 3 pi over 4. So here is a minus 3 pi over 4. And now we can draw those vertical asymptotes. So here is a vertical asymptote. Whenever r are the blue points, we already know we have a vertical asymptote of the cotangent function. And as we said before, a tangent function and a cotangent function, they have vertical asymptotes. Okay, so here it is. And now if we want to graph the function, let me graph with some different color, or maybe green I didn't use. So the graph of the function is going to be this way now. It's going to be from here, is going here in this position, and from this position going down. So the form is approximately this way. Same thing, this period is going to repeat. So this is the second period. So I already have 2 periods. But anyway, let me draw another third period. And this can be repeated in all throughout x-axis because this is a periodic function and it goes from minus infinity to infinity. But we were interested just in 2 full periods, but in fact we have 3 full periods. So this is here. If we are looking for the domain of this function is from minus infinity to infinity, except when x is a vertical asymptote. When x is a n pi plus pi over 4. In this position here we are not going to have any, is not included in the domain. So those points are excluded from the domain. But if we are looking now for this point of intersection here, so I'm trying to find all critical points. At this point here, it means we want to find the y-intercept. To find the y-intercept, we set x is equal with 0. And y-intercept is going to be equal. Okay, so now instead of this function 1 over 2 we can write. And we can write a cotangent whenever is x, we plug in 0 minus pi over 4. And a negative pi over 4, cotangent in negative 5 over 4 is a minus 1. But we already have this 1.5 in the front. And when we multiply minus 1 times 1.5 is minus 1.5. And this point here is going to be equal with x is a 0 and y is a minus 1.5. So this is the y-intercept. And if we are looking for the range of the cotangent function is from minus infinity to infinity.